Good afternoon, everybody, and welcome to our webinar. I'm going to give everyone just a minute or two here to enter the room, and then we'll get started. All right, it looks like our participation is leveling off, so we're going to go ahead and get started. Welcome to the National Center for Rural Road Safety's February webinar entitled Blowing Snow Mitigation Strategies, Prioritization and Implementation. My name is Jamie Sullivan, and I'm the Director for the National Center for Rural Road Safety. This webinar is being co-hosted by the NLTEPA Safety Work Group. It's going to be about 1.5 hours in duration. To activate closed captions for their webinar, you're going to click on the Show Captions button at the bottom of your screen. We have a logo shown on the PowerPoint right now to depict what that looks like. You can also adjust those captions under the caption settings at that same button. We will be recording today's webinar for archival on our website, and you will be able to access that within the week at ruralsafetycenter.org/webinar-archive. We do have a question and answer pod that we would love for you to put your questions in today. We're going to have quite a few speakers today. So the best way for us to find those questions that you might have is in that Q&A pod. However, we do also have a chat pod for you all to share resources with each other and information. You can also alert organizers of any technical difficulties you might have by also using that Q&A pod. Again, it will be the easiest way for us to see them as that chat pod does get quite busy. We do have handouts available for download today, and I will put the link into the chat pod for you as soon as I introduce our first speaker. We will have at the end of today a feedback form at the end that we would love for you to fill out. Most importantly, we're looking for topics that you would like us to address in future webinars for the rest of this year. And as always, certificates of completion will be presented to you within a few weeks after this webinar. And with that will be an application for the more formal CEUs if you are in need of those as well. We do have a few announcements for you. We have released our next episode of our Home Safely podcast featuring Nick Parr, who's the director of Boone County Highway Department in Indiana. In this conversation, he talks about his decades-long experience in rural road safety, how the Boone County Highway Department has evolved over the years, and also how they use opportunities to identify and implement the safe system approach. So we'd love for you to take a listen to that. It is available on our website under our podcast dropdown, or you can use this QR code. In addition, we are running our Road Safety Champion program, and starting this coming Tuesday, we are beginning our planning and engineering modules. They will be held every Tuesday from 1 to 3 p.m. Eastern. And then starting this Wednesday from 1 to 3 p.m. Eastern, we will be hosting our public health modules. And again, those QR codes on the right will lead you to the website to learn more about our Road Safety Champion 101 program, as well as how you can register for those particular modules. And then lastly, our partners at Federal Highway Administration have recently released a new rural road safety webinar series that we wanted to make sure you were aware of. The very first webinar in this series is tomorrow from 1 to 3 Eastern and will be on accelerating delivery of road safety projects in rural areas, successful implementation of modular designs and materials. And then there will be another one held in May on the 21st from 1 to 3 Eastern on innovative funding processes for rural road safety. They also are planning for a fall webinar and a winter webinar as well. And when those registrations are open, we will make sure to let you know about those as well. But the QR codes on the right side of the screen right now will bring you to how you can register for those. Again, this information will all be part of the download that you can access as soon as I introduce our first speaker. So as I mentioned, we have a lot of experts on our webinar today, and I'm very excited to introduce them all. We have several people joining us from South Dakota Department of Transportation, and then we also have two researchers joining us from the Western Transportation Institute. And they're going to be all speaking today about blowing snow mitigation strategies, prioritization, and implementation. Our very first speaker is going to be talking about the motivation for South Dakota Department of Transportation undertaking a project to mitigate crashes in rural areas due to blowing snow. Danny Varlick is a winter maintenance specialist with the South Dakota Department of Transportation, where he has dedicated 11 years to maintenance operations focused on improving winter roadway safety and performance. In his current role, he serves as the chair of the Clear Roads Consortium Technical Advisory Committee, providing leadership and direction for multi-state winter maintenance research initiatives and helping guide research priorities that support practical, implementable solutions for transportation agencies. Since 2017, Danny has been extensively involved in the planning, design, and maintenance of snow fence systems, applying data-driven approaches to reducing snow drifting, improve roadway reliability, and enhance driver safety. His work integrates Department of Public Safety winter crash data with operational metrics such as material usage and labor hours, leveraging automatic vehicle locator systems and maintenance data collector systems installed on snowplows. By analyzing these data sets, he identifies recurring snowdrift trouble spots, evaluates treatment effectiveness, and supports targeted maintenance strategies that optimize resources while improving winter maintenance outcomes across the state. And I'm excited now to hand over our webinar to Danny.
All right, thanks, Jamie. All right, can the sound and video showing up all right for everybody?
Looks great.
Okay. Well, thanks for the introduction. I am Dan Varlick. I'm the winter maintenance specialist for South Dakota Department of Transportation, and I'll try to get us going. So when we talk about winter safety within South Dakota, one of the first things that comes to mind is snow and ice on the roadway. However, that often gets overlooked, especially outside of our maintenance circles. So from my perspective within the DOT, blowing snow is probably one of the most persistent, dangerous, and frustrating contributors to our rural crashes during our winter months. Blowing snow doesn't behave like our typical winter hazard. It can turn a clear roadway into zero visibility situation in a matter of seconds. Drivers may not encounter slick pavement at first, but they will encounter whiteout conditions. This is primarily due to our high heavy winds and light snowfall that we get during our winter months. So with that, the sudden loss of visibility leads to lane departures, head-on crashes, and multiple vehicle pileups, especially on our 2-lane highways where there's little room for error and no median separation. So what really motivated the DOT to take this on as a department is we see the same location over and over again, that we see a lot of these random crashes. So we're getting to be where they're pretty predictable. And so we tie them in with the wind direction, surrounding land use, topography, and kind of looking at drift patterns. Luckily, our operators are very familiar with our roadways, so they know exactly where these trouble areas are. And then I just confirm it with our crash data, or confirm the crash data with our maintenance data that we get from our AVL data collectors. And then we can also see where we're spending a lot of maintenance time, plowing, and also material usage in those specific areas based off of our MRM locations. So what really drove this was after our 22-23 winter season here in the Midwest, it really came clear that we really needed to be reactive on some of the snow mitigation. Currently, we're really good at responding to the storms at hand. Our crews are out applying material, keeping the roads clear and open, and under those extremely challenging are the conditions. But the blowing snow is one of those hazards where maintenance alone can't fully solve the issues at hand. You can plow the road perfectly, and 15 minutes later, even sometimes less than that, the road's drifted shut again. And then our guys have to go back out and just it's back into a whiteout condition. So after realizing that, we kind of went ahead and we brought up I kind of drafted the proposal. And from there, we kind of brought in the research, and that's where we got Natalie and crew from MSI all involved. So that's kind of that's what kind of brought the motivation in, is where we really wanted to protect the traveling public, as well as we wanted to make sure that our roads were being safe, and then as well as our maintainers were being safe. So that's where we really concentrated on the rural highways and kind of wanted to go there and see what we can do to develop a plan or a guidance document to move forward to help our field level staff, area engineers, region engineers, on what we can do differently to help mitigate this on our rural highways. But that's really all I have. That was kind of more of my motivation, I can't speak, sorry. But the motivation that really brought on this project. So I'll leave it back to you, Jamie.
Perfect. Thank you so much. And so you heard Danny talk about the staff out in the field who is working towards mitigating this blowing snow. And so we're very excited right now to have two of his staff here to talk to us about some of their challenges, as well as some of the innovative practices that they use. And this information was used in the research project that you'll hear a little bit more about after. So our next two speakers will be Dean Vandewille, who is the Pierre Area Engineer for the South Dakota Department of Transportation. He oversees construction and maintenance activities for South Dakota DOT Pierre Area Office, along with staffing and budgetary responsibilities to support those activities. Prior to his current role, he also served as a field engineer for South Dakota DOT's Aberdeen area, a road designer for Burns and McDonnell Engineering, and a South Dakota DOT Office of Road and Design, as well as a supervisor in the South Dakota DOT's Office of Road Design and Project Development. He has a Bachelor's of Science in Civil Engineering from South Dakota State University and is a registered professional engineer. Joining him will be Jared Fosham, who serves as the Highway Maintenance Supervisor for the South Dakota Department of Transportation in Phillips, South Dakota. With over 23 years of experience in road maintenance and operations, 14 of those years as a highway maintenance supervisor. Jared oversees a 7-person team and 2 seasonals, which include the Phillips Shop and the Hayes Shop, responsible for maintaining 424 lane miles in the Pierre area. His work includes managing snow and ice removal, coordinating repair projects, and ensuring compliance with state safety standards. I'm excited to turn the presentation over to them.
Good afternoon, Dean Vandewille here, and thank you for having me. I'm going to start quick with a geography lesson for those who are here. So we'll take that moment and pull this up for everyone. And so someone give me a heads up, you're seeing the screen?
Yes, we can see.
Yes. Awesome. So being a Minnesota native, when I went to college in South Dakota and I was making friends, I would ask them their phone number and I would ask their area code, and they immediately knew I wasn't from South Dakota because South Dakota is one area code. This is very rural country. And the reason I bring this up is, as far as the map where the dot touches, is we're in Pierre, South Dakota, our capital of our state. And on each side of the state is South Dakota 1804 and South Dakota 1806, which were the 2 years Lewis and Clark went up and down the Missouri River. And the reason I bring it up, and it's kind of interesting to hear the engineering comments in my introduction, because a lot of the problems in things they're asking me to address today really come down to the point of, okay, snow fence themselves and when we use them and how. And typically, we're looking for crashes. We're looking for average daily travel exceeding a number. Engineers love to have thresholds or triggers of when we put on shoulders or when we put on paved shoulders or when we widen all these different things. And the problem with what I'm about to show you is where we put this what we call a Wyoming snow fence, because we adopted it from Wyoming, is in a location where we don't have data, which engineers desire to justify the cost for a project. It really came down to maintenance sharing with us this continues to be a problem area. So South Dakota 1806 comes south out of Fort Pierre and continues southeast. And there is an area that I'm zooming in on, and I'll show you where our physical snow fence went in, where staff continued to tell me that it was presenting a tremendous problem for them. And the route they run, I'm zooming back out, hopefully slowly and not making you dizzy, is about a 50 mile one direction, one truck, one snowplow. So this is about mid-span on that route where I'm zooming in. And what would happen is not only could you not handle two-way traffic, they couldn't even handle one-way traffic. It would blow shut, much like Danny said. And so we had stranded motorists in here. And part of my job to help folks like Jared is to get him all the toys he needs. A six-wheel drive snow plow, a road grader, different chemicals if he wants to use magnesium chloride or calcium chloride, or we work with a farmer to put up snow bales here to here this winter, or maybe we pay a farmer for corn rows from here to here for drifting this winter, and we do an agreement. But this location that I'm zoomed in on, and I'll go in close, actually is a location where it was really handicapping our crews. We were spending tremendous time in this roughly 1 mile, and it was killing our ability to service the rest of the route. So for me, part of my job is how do I help staff get up and down the road where they can serve the most customers? What you're seeing in plan view, and I'm going to trace it here, is you are seeing the fences, and I'm going to zoom in that you can see them up and close. But this is one stretch right here of physical snow fence that we put in. And we started working with the Lower Burl Sioux tribe, who was strong advocates and proponents to work with us. It's the land they own. And Danny Varlick, who introduced this presentation, helped me in that he evaluated wind direction and how this channels through. And so zooming in, when we would actually get folks stuck, there would be half a dozen or 6 locations that would drift solid. And if you look at the height of the road to the right and the height of the road to the left, this would be extreme solid snowpack. So it took us 2 years to bring it to fruition, but we actually built, again, what we call the Wyoming snow fence based on wind direction and locations when Danny evaluated the contours would be a good angle and that would intercept. And Danny, I'd like you to correct me or affirm what I'm about to say. Typically, our drifting is about a 250 to 1. So it was also critical to study the contours and to study the offset. True, Danny?
That is correct.
So, just an interesting point there. And I'll show you a little close up from our plans then. And this is actually, it's a very simple A-frame that's 8 foot tall. And basically we let to contract, and so we had to secure the right of way in order to do it. But the Lower Burl Sioux tribe was wonderful to work with, and they were strong advocates to help patrons get to and from home, obviously. So that's the detail there. And I'll go back then to the big thing that you saw is this snow would pack in here so hard that all the toys, if you will, that we would give our maintenance crews, we were ramming it with a 6-wheel drive. We would ram these areas with a blade and not be able to get through. And so anyway, I'll show you also a photo. Danny mentioned 2022. This is how hard packed the snow is. I am not a small guy, but I won't say I'm huge. But I am 6'3", 230, and you can see the indentations I'm leaving on the snow. And that's the exact same sign and the butte of where our snow fence stopped. So for us, what we saw in results was immediate. We had a tremendous 22 blizzard, and we got this in just prior to the next season, and it was crazy insane how positive the ramifications were of the snow fences. Now, the drifting was massive. And the problem we had is and one of the things they wanted me to comment on was pros and cons. And we put a perimeter fence around because these are pastures for farmers to rent. But the drifting was so extensive, it actually crushed the perimeter fence. such the cattle came in and they'd start rubbing on our Wyoming snow fence. Crazily, they broke a good 20–30% of the members that our maintenance forces had to go out and reestablish. So the last thing I'll mention is this is not something that's common to me. I would say in western South Dakota, they use these types of wooden snow fences fairly prevalent. And obviously, Wyoming is the name we stole it from. So, and I've seen them out there a lot. Another consideration I'll give, and I'm about wrapped up here, is we have another location where we had tremendous stranded motorists as the snow flies. This is US 83 to the left. And we wanted to do a living snow fence at the location I showed you. But the problem was the soils along the river were so terrible that when we talked to agronomists, they're just like, it's going to be very infeasible to try to maintain a living snow fence in these heavy type clays that are deposited along the river. As you see by line 20 miles by the crow flies, soils have changed dramatically that this coming summer, we have worked, and Danny has helped me with this as well. And we'll be putting roughly 4,000 feet of living snow fence. And I've worked with DNR, a conservation district, a local conservation district will install. Our maintenance forces will water. And I will end my part with saying, it looks like the cost of the living snow fence will be around $20 a foot for roughly 4,000 feet. And our wooden snow fences that I first showed you in 2022 went for about $80 a foot. So that gives you some comparisons. And again, it's just really trying to help maintenance forces do the greatest impact they can by getting up and down the road. So that's really the extent, very quick down and dirty of the snow fences we put in. And I'll look to turn it over to Jared Fosham, maintenance supervisor in Hayes-Phillip.
And Dean, while Jared's pulling up his PowerPoint, we did have a question that makes sense to ask you now. In that discussion that you just asked, you mentioned a 250 to 1 ratio, and someone's wondering what that ratio represented.
Oh, sure. It's like basically a 250 to 1 is the rate that snow drifts. So if you put the snow fence too close to the road, basically these are long, flat slopes because they're normally wind induced. So if you have an 8-foot tall snow fence, you got to figure that for every 8 feet or every foot vertical, the drifting is going to go 250 feet horizontal. So when Danny helped us in setting the distance away from the road, that was taken into account. So you don't have this big, massive snow fence, but it's so close to the road that drifting actually goes over the road versus stopping the drifting prior to the road. If that makes sense.
Yeah, and Dean, I can add to that. So typically, the design standard is 35H to your center line. And with the way the amount of snow and how far it carries with nothing to protect it, we had to kind of redesign this one, because if I would have just done the normal height, the normal calculations, we still would have had some issues. And then with usually in the wintertime, we have 60 to 70 mile sustained winds, real similar to Wyoming. So I didn't want to go with a very high fence. Just due to possible with the structure being busted down. So I stuck with an 8-foot fence and just did a longer setback to accommodate not having the storage area, because it was a huge cut section where there's nothing that we could have done on the downwind side. So there's kind of some special design features I had to do on this project. So it's not your normal design standard, so it's kind of hard to explain unless you are actually there and kind of seeing how everything was working.
And the only other thing I'll add is there was probably a good year of time where Danny was studying prominent wind direction and the contours to really determine how to maximize the use of the structure once we built it. So there's definitely some homework that needs to be done here to make them efficient.
Perfect. Thank you guys very much for answering that question. Jared, we can see your presentation.
Okay. I'm Not going to talk about snow fences as much as more kind of how to manage the snow when we're out plowing. You know, different things that have helped for us. Not saying that they'll work for everybody, but they've worked pretty well for us. This picture here is just one I've taken off of a web camera. It shows, you know, using snow bales for a snow fence, and then down the road a little further, you can see somebody's blowing snow down there, which I just thought it was kind of interesting. It's a pretty unique example of how much work actually goes into managing the blowing snow and things you can do to prevent it, you know, such as snow fence, and you know what you can do to prepare for the next snow event. This here I took on I got a 26-mile commute coming to work in the mornings, and I took this on my way to work. You can see the road surface is actually pretty good, but this is actually a bridge right here where it drifted in, and just as you guys are aware, you know, even getting to work can be a challenge some days. To me, visibility is the most dangerous part of blowing snow. Snow and snow drifts on and icy roads are something that you can deal with, but it's hard to deal with things that you can't see. The driver in this truck abandoned the truck in the middle of the lane in near zero visibility conditions. He didn't turn on any hazard lights, didn't put triangles out or nothing like that. The local sheriff and I, we stayed out there on 16 hours waiting for this thing to get towed off the road. We just parked a little ways back behind it with our strobe lights on to try to notify people before they got to it. Thankfully, there isn't a lot of traffic out when conditions are like that, but there's still people there. There's been times when visibility gets poor like this where we have pulled our plows off the roads. Me personally, I leave it up to each individual driver as they know their conditions, they know their capabilities and their comfort level when out in these conditions. Excuse me. On this here, there's open farm ground stuff to the north, and you can see on the edge of the shoulder, the plow driver, he was concentrating on trying to stop the snow from blowing because he had drifting and sticking on the road. Well, it wasn't a very good decision. He did this for about an 8-mile stretch where he stuck his wing down over the edge of the shoulder and made kind of a trench there to try to stop the snow from blowing. And in turn, what he wound up doing is he wound up getting the snow pushed up higher than what the road surface is. And you can see where, you know, it starts drifting off of it. When out plowing like that, it's hard to not get caught up in the moment. You know, he was more focusing on the ice and the snow on the road, and he should have been looking probably more at what the damage of what he was doing was going to be causing, you know, down the road. You know, you need to stop and think about things, you know, when you're out there doing stuff like this. Try to make sure you're keeping your windrow lower than what the road surface is. And if the ditches get full, take and just try to taper your windrow down, you know, so the snow keeps moving across the road. Because in my experience, you're not really going to stop snow from blowing across. You can only manage how you're going to keep it moving across the road. As you can see here, you know, the windrow, it's caused the snow to build up higher than what the road surface is, which creates catch points for the snow to build drifts faster and deeper. The snow, it kept accumulating worse, and then we didn't have no place to push it to help with it at all. And then we had to get out the snow blower to try to get things kind of pushed back and try to clean up what that caused to try and get ready for the next event that was coming. This kind of helps to show why it's so critical that you try not to push it up tall like that. You can see most of that kind of on the backside of this drift where the snow could have been had he not started ridging it, and it just kept building and getting deeper. If this situation does occur like that, where the snow actually gets higher in the ditch than what the road surface is, you just try to do your best to try to angle it down to the road so it just keeps blowing across instead of building up and getting deeper. And this kind of shows it a little bit better too here, just actually how high he was getting up, trying to push it up, and it kept making everything worse instead of better. About 2 days after we was trying to get that cleaned up, we didn't get finished with it. We had another storm that had come through, and with this one, it plugged the road up. We fought it for, the road was pretty well blocked for about a full day, and we fought it. There was a local guy that was having a heart attack. He was trying to get to the hospital, so we wound up, we had a truck blower and then 2 loader blowers working on this about an 8-mile stretch here. And a lot of this just could have been prevented. It wouldn't have stopped at all if he had not windrowed that up. We would have definitely had issues, but it wouldn't have been near as deep, and would have been able to get it opened back up easier had he not. These are just more pictures that kind of show these drifts were somewhere around 8 to 10 foot deep here. It really plugged things up. Some of it was to do with the lay of the land. Some of it was to do with how he had his windrow pushed up. You can kind of see on this, where he was pushing it up, and then the snow back behind it again here. How much worse it made it just by trying to stop it from blowing. In this photo, you can see what using too much chemical can do when you have blowing snow. The bare side of the road didn't get any salt on it. The side with the snow on it was salted the night before. I took this picture just shortly after daylight the next morning. We tried to use as little as salt and mag as possible. Once the ground freezes, we hardly use any in the rural areas. We pretty well just let the snow blow across and just try to keep it moving instead of putting salt down and stuff. And the salt will start melting and it starts building up.
So Jared,
Yes.
Just some comments here. This is a location where our shop meets another shop, and our customer
Yes.
is quite a bit different than their customer. Their customer is interstate traffic. And so this is US 14 is this location, and this is where, again, Jared's crew, High Fives, and adjacent crew, and their practice is not wrong. It's serving their customer. They're seeing a lot more I-90 traffic who likes to go very fast. And once you get in the cycle of having to put chemical down, you have to keep putting chemical down for those that know. And where you see on Jared's side, the near side on the left photo, by not putting that chemical down, they don't have that residual in the road to actually catch that moisture and cause that freeze condition. So I would say it's understanding your customer, how they drive and their abilities. And in Jared's crew, if you can get away with not having to put the chemical down, they have found that this can be how do I say this, a treatment option, if that makes sense. But once you start going down the cycle, Jared, you got to keep going, correct?
Correct. And in their defense too, they have a short stretch of 14 right here, and they concentrate a lot more on the interstate, so they probably try to hit it hard so they can get back to the interstate, I'm sure. And one thing, we always watch it when we put chemical down. We try to do it fairly early in the morning, so we got the day for traffic to kind of wear the chemical off, and we'll plow it off. That way, your chemical's there when you reached the warmest point of the day to where it's actually maybe going to work. And then we try not to reapply at night unless we got ice. And then if you have ice, there's not much you can do. You about have to do something. So I guess my point being is, watch the wind forecast really closely and the blowing snow chances before you decide to put chemical down, because it can really bite you in the long run. We have had it too by not putting chemical down. Our road might look like this with the snow stuck on it, and without putting chemical on, you get the snow blowing across there all night. It sandblast it in a sense, and it'll eat the snowpack off. We've had that happen several times. Blowing snow isn't something that we can stop, but good techniques and good judgment, solid understanding of how it moves across the landscape. Every storm's a little different, but it can sure help manage, what you're going to do with it. Every storm teaches us something new. The example shows how small decisions like pushing up a windrow with your wing or when to use chemicals can make a big difference in the long run. And that's pretty well all I got. If anybody got questions or comments, I'd like to hear them.
Perfect. Thank you so much. We do have several questions that came in, so I'm going to ask each one of them, and then whether Jared, it's you, Dean, or Danny to answer them, any of those are fine. Our first one that came in was, did you consider increasing the width of ditches or grade line adjustments to increase your snow storage as long-term solutions?
That'd be more a question for you, Dean. We do try to mow out more in our ditches in our fall cut, so we got more room for storage. But as far as the grading, I'll let Dean answer that.
Typically on our grading, we're looking at back slopes, and storage will do a standard ditch that's a 4-to-1 in slope, and we're about 4 feet down to the bottom of our ditch. If the north and west sides are, if we have prevailing drifting issues, we'll go to a 7-to-1 back slope to create, and our DOT calls an in slope off the shoulder, your ditch bottom, and then a back slope to natural ground. We'll go a 7-to-1 to try to get more storage and capacity. And then in Jared's maintenance manual, it gives him the prerogative of where they think they have drifting. We always do a minimum of a single cut of grass before the winter season starts, but he has the latitude to mow out the entire ditch width or part of it if he knows it's an area that he wants to get additional storage. So I hope that addressed the question.
Yes, thank you very much. We have several others. Another one that came in was, how do you handle agreements with landowners to support mitigation efforts? Are most willing to participate?
That one can be taken by really all of us. Danny has guidelines that he's created. He's in our operations support office, and there's 12 offices like the one Jared and I work for in our state. And so Danny has examples of, we use like SDSU. Say we want to rent corn rows, and we want you to leave corn rows in this winter. So basically, we look at how many acres we're talking, the location. We go shake hands, and I think we offer the landowner a set rate of like double what he would make anticipated price and profit rental on the ground, and to leave it in place. And so we can do it a couple different ways. We can do the formal if we're wanting to take a farmer's crop. We compensate them through a Department of Transportation agreement. And that agreement is done, again, Danny, as a shell document. I take that shell document, I go meet the farmer with Jared, and we come to an agreement and it's done. And then the DOT will compensate. Or Jared can go out and simply shake hands with a farmer and say, hey, could you put the round bales that you're stacking from here to here instead of right there? He can just do a gentleman's agreement where there's nothing formal. I tend to like to do something formal just because I want to protect the landowner in case I leave ruts in his field or something like that. But Jared also could go out and shake a farmer's hand and say, could I throw up some orange fence? I'll tear it down in the spring before you farm or hay or whatever you do. So there's a couple of options there of how we actually compensate the landowner. And it's now with the formal fences, the living snow fence and the Wyoming snow fence, those are lease agreements. That one was with Lower Brule Sioux Tribe. And then the living snow fence, we would actually pay the landowner if it was on private for rental of the ground. Or in my case, that is a national grassland. So I had to get a permit with the national grasslands in order to put the living snow fence as you see it. So there's no consistent, it's wide and varied pending how permanent the feature is. And Danny, Jared, anything to add to that, or does that kind of hit it?
The only thing I guess I would add is another thing we've did on a gentleman's agreement. We got a V plow that will fit on our loader. We have went out in the field, where if we got a spot where we're having troubles with it blowing and drifting on the road, and went and made snow ridges out in their field. We've did that just off kind of a gentleman's agreement.
And then to add on to it, another option that we do allow, and we will compensate the landowners too, is we will utilize if they don't have hay or anything or corn stalks. Sometimes they'll have silage bags that they'll fill with grain and so forth, and then we will kind of do some planning prior to harvest. And if we know it's a troubled area, we'll either do a handshake agreement or we'll actually go into an actual agreement to where we will compensate that landowner based off of whatever the future crop prices are or what current prices are, whichever will compensate them the best. We'll actually have them put those silage bags a certain distance off the road to help with that mitigation as well, if we don't have the standing corn, et cetera.
So one last thing I'll add is in our state, South Dakota State University in Brookings, South Dakota is a large agricultural college. And if you go to their website, they do a production, or not a production, just data on what the going rate for rental ground is for haying or for crops in any county. And then they'll also give, basically just that. So we can go in and see what the rates are on average and then compensate them accordingly and go to them with that and say, here's what it looks like it's reasonable in your county. Is this acceptable? So it kind of gives us a baseline to start on what average land rental is.
Well, thank you guys for those answers. We do have quite a few more questions, but we also have 3 more presentations. So I'm going to go ahead and move on to our next 2 speakers right now, and then we will come back for questions again at the end. So if you have more questions, please keep putting those in the Q&A, and we will ask those at the very end of today's presentation. Our next 2 speakers are going to be Natalie Vilwak-Whitty, who is a senior research engineer with the Western Transportation Institute at Montana State University. At WTI, Natalie performs research to address the needs of local agencies, state departments of transportation, federal land managers, and the Federal Highway Administration in the research areas of safety, winter maintenance, public transportation, bicycle and pedestrian travel, and workforce development. Natalie values working cooperatively with research sponsors to address their needs and ensure the technology transfer of the outcome. And Laura Fay is a research scientist at the Western Transportation Institute at Montana State University and has conducted and led research in the fields of winter maintenance operations and low-volume roads since 2006. She manages the Cold Climates and Operations Laboratory and Research Focus Area. She has dedicated her career to supporting state, federal, and local transportation agencies in the identification and implementation of best practices through applied research. She is the current committee chair for the TRB Low Volume and Rural Roads Committee, AKL 17, and I am excited to now turn it over to them.
Laura, are you loading up the slides?
Yeah, I'm bringing them up, and let me get
Great.
presentation mode.
So as she's bringing those up, you can see the slides here. So you heard from Danny first, kind of that really high level from the state, kind of the motivation behind the need. And then you heard more details from Dean and Jared regarding kind of specific experiences they had in their area. And I'll talk a little bit more about that too, which was used within our research project here. So that South Dakota blow and snow mitigation strategies, prioritization and implementation. South Dakota 2023-06. So next slide, please. So there were 4 main objectives with this project. And so hopefully you'll see how kind of all of this is tying together at this point in time. So really that first objective is looking at more of that background information, which encompassed, of course, literature review. I saw some folks talking about questions in the chat regarding specific things. So, other entities and states have been doing great work on, I know, living snow fences and whatnot. So the document has kind of that latest and greatest compilation of what's been going on. It also involves talking with other state DOTs and, of course, speaking with folks within South Dakota in the various areas and better understanding kind of what their challenges and issues were, which you heard a lot from our previous presenters. Another objective was really trying to understand regarding that wildlife experience when we kind of implement these things, because there's concerns on that topic. Spoiler alert, it's still one of those areas that there is kind of a need for research as we consider that more fully. And then the third objective, which I'll highlight more of this, is kind of trying to prioritize those areas, right? So you heard from Dean kind of that experience of looking at these various pieces and so forth. But when we look and hear from the various areas, I have a problem in this specific area. Some of them are more micro, and then some of them are more of those extensive kind of links that you might see. So trying to understand what those needs are, and then trying to look at that more planning level benefit cost analysis to try to think through which ones might be prioritized for a various reason, and thinking what that cost might be. Because of course, at the end of the day, as a state DOT, you need to be fiscally responsible. So ensuring that we kind of look at that best case scenario and identifying funding types. And those are changing over time as well. And then objective 4, you're going to hear from Laura next, who's going to give you highlights of the guidance document that we worked with South Dakota in implementing based on kind of all of the project itself. Next slide. So as I mentioned, one of the first things to do to really kind of get the latest and greatest information, because while we have project reports, we know that practices are changing based on experiences like what Dean kind of talked about. So there was an interest, and you saw kind of that geographic representation of the Missouri River in the central part of South Dakota, essentially. And that makes kind of a very unique experience. One of the first things we heard was kind of the East River, West River. And generally speaking, well, you heard some nuances associated with that. Kind of that West River is more of that arid environment, so more of the challenging associated with growing things like a living snow fence or plants. And that east is that agricultural, which brings challenges as we're identified in the sense that how does that land trying to work cooperatively with folks when you have that high value of land for use in agriculture, and then trying to implement some of these solutions, what does that look like? So we talked to the various entities with the states. And again, if I spoke to anyone on the line, thank you very much for taking the time to do so. We learned more about kind of the planning, the design that was done, and maybe some changes over time that they found, how they construct and how they maintained it, and even how they funded it. And some things that we kind of heard about were kind of the issues of guardrail, even serving as kind of those barriers or collectors. You even heard from our earlier presenter about kind of bridges causing that issue too. And so trying to look at some of the issues that were experienced. Next slide. And then a big piece of it was to obtain the input from South Dakota itself. So we spoke with folks within the 12 different areas of South Dakota. So that's kind of how they divide the staff. And you heard from the peer area today. So that kind of really great detail about the challenges that they were experiencing to make sure that that was infused to what we were recommending within our literature. So that really served as the foundation for identifying the blown and drifting snow locations. There was one kind of unique area in Aberdeen in the fact that they took GIS kind of data collection of it, but that was a little bit unique compared to the rest of the states we talked about. And it created kind of a different database, which we had to try to synthesize when we looked at it. And again, you saw the challenges with it, with the basic topographies and how the roadway sat with it and what that meant about drifting snow, and kind of the other nuances of how you might want to consider, those slopes that I saw a lot of discussion being talked about and so forth. We also learned about kind of how people currently were funding things, in large part from this project, which also has influences regarding kind of when we might implement it, but even some other potential solutions that folks had as well. And we heard a little bit about kind of preferences for a variety of snow fences for a variety of reasons, whether it might be, as Dean highlighted, we know we want to put a live-in snow fence here, but we know it's also going to be a little bit more challenging to get that started in this more arid environment and so forth. So that was kind of integrated into what we did. But again, really great foundation from working with folks in the various areas to identify that base information about what locations are causing you problems. Next slide. So that resulted in a total of 181 locations, which you see here. And I think this map is kind of insightful because it kind of shows you the variety of what was shared with us. And this is a little bit reflective of kind of the type of rural roadways that are in areas, just kind of the needs based on some of that weather and the experience of blowing snow in different parts of the state. Some of the other kind of nuances and challenges with it. And it was a lot of kind of iterative back and forth. We talked with folks, we put it, our colleague Carolyn Klauser put it into like the GIS, and then we shared it back and said, did we hear you right? Did we fully understand? Is this the correct thing? So there was a lot of work to make sure that we accurately captured what was being told to us for this effort. And then ultimately the goal was, as a part of this project, that South Dakota wanted to understand what were those top 100s. And so I'll go to the next slide to share a little bit about how we prioritize that. So these 6 data sources were the ones that we ultimately used. We did consider other ones, but for a variety of reasons, they may have been put on the wayside, and it's kind of those incomplete data sets and so forth. But just kind of step through these a little bit. Again, maintenance area feedback, instrumental to identifying those locations as a whole. But then when we thought about, how are we going to prioritize it, you heard about kind of crashes and incidents. And it was actually in conversations with the P area where they identified kind of slide-in data. So the experience that you might not have a crash report in the end, maybe someone hit a blow in snow that was across the roadway, they went off the roadway, but there's really no damage, they were able to be pulled out. So it's not necessarily going to generate a crash report. So trying to integrate that along with the crash data that we had as well. We looked specifically at crash data regarding blowing snow, and then winter weather, which was more encompassing than just blowing snow. So some of those sleet conditions and so forth. Winter road conditions, kind of that variety of, do we have snow on the road? Do we have slush? To really try to integrate some of how this might be captured within crash data, which isn't necessarily cut and dry. If any of you have worked with crash data, you kind of understand that in more details. So that was looking at up to crashes. We had data from 2014 to 2024. So just under 200,000 data pieces. And then for the slide-ins, a lot smaller, just under 1,000. And so that kind of provided that risk experience associated with blowing snow itself. And then kind of from the roadway functional classification, we really wanted to get that measure of, while these are rural roadways, so not our interstates, but there's still some that have more of that priority need than others. So the functional classification allowed us to capture that. And it also provided kind of a proxy for traffic volume, AADT, or average annual daily traffic. And then there's a really kind of great way to look at that economic experience when we were kind of thinking about the distance from the maintenance shed. So Jared talked about kind of the sheds that he oversees within his area, and there's those, spread throughout the state, right? But the blow and snow locations are not necessarily, in proximity to those. So part of this effort, which was using an ArcGIS closest facility analysis, is it helped us understand if locations are further away from where those sheds are, we know that it might take folks a while longer to get there. So if they're seeing a reoccurring need, and if there's a long experience for kind of looking at that specific area, it's not like a micro one, it's kind of more of a corridor experience. The prioritization helped take that into account. And then I did want to highlight kind of the prevailing wind, which Laura really took on. So that's data from the RWIS, so Road Weather Information Systems, from 2014 to 2024, but specific to the winter months. So a little bit expansive in the sense that it's, I think, October through March, which resulted in more than 33 million data pieces. So you can start to see kind of the data analysis that was done. So drawing on kind of that really experiential thing, and then taking the data that we had and trying to inform what it looks like. And that's where you see the wind rose diagram there, where we kind of see that there's a high frequency of wind coming from the northwest direction during these months, which coincided also with what we heard from maintenance area folks as one of their primary kind of issues to address with. And then the final data piece that we use in prioritization was the land ownership, which we drew from the Protected Area Database of the United States, so PAD US. And it was allowing us to see if any of that data was within federal land or tribal lands. Because as you heard from Dean earlier, we want to have that understanding because there might be additional nuances associated with kind of processes that might have to go through when we think about kind of the micro aspect of what is it going to look like if we're going to implement a snow fence on that area. We try to look at state-owned and private-owned data, but there's not necessarily a readily available data sources. So these data sources were used to prioritize these various locations. And ultimately, Laura, if you go to the next one, these are the top 100 blow and snow areas. And if you can see the micro numbers in here, again, you can look at the presentation later if you want to kind of look at more details. It shows you which ones are kind of from 1 to 100. But ultimately, and I'm sure Danny will kind of allude to this a little bit, you might implement one in one area if it's a certain lake that fits in a budget, or maybe another one. But they know kind of within the top 100 that these are kind of the ones that we can address these in the rural areas. These can really kind of bring a benefit to those that are trying to fight this blow and snow across the state. Next one. Next slide, Laura. Thank you. So the last slide that I'm going to share with you, and then, like I said, Laura's going to dive into kind of the guidance document that was created as a part of this, is ultimately the report that I mentioned will be available at this website, and you can find kind of the nitty-gritty details of the prioritization process if you want to learn more about that. So Lauren, I'll pass it off to you.
Great. Thank you, Natalie. And thanks everyone else who's helped present this work. So the last piece of this effort was we identified these 100 sites. Now, what can we do to help support implementation of snow fences or blowing snow mitigation at these sites? So we came up with a guidance document. And the general outline is, what are all your options for blowing snow treatment mitigation? And then how do you know which one is going to be the right one for that location? So those are the pieces that I'm going to talk about next. So there's been a lot of talk of different snow fence types. So I'm going to run through kind of some pictures and some concepts of what those are. So a Wyoming snow fence was mentioned already. So this is a picture of that. This is a structural snow fence. Structural snow fences are typically made of wood, polymer, I-beams, basically any permanent type material. They can be varying in height from 4 to 14 feet or taller. They are typically anchored well. You don't want them tipping over or blowing over or getting moved. And as mentioned already, Wyoming has quite a few of these, which is why it's called the Wyoming snow fence. But there are other ones that I'll show next. So on the left here, in this image, we have a picture of a vertical snow fence. So this might be a good option if you don't have, for example, permission to put something as large as a Wyoming snow fence on the property. It will behave differently, but it is there to help you as another option. Another example on the right is cribbing, which is commonly used also as temporary fencing. And in this example, it's put right on the right-of-way fencing. So that is another option as well. Some other examples of structural snow fences that have been used out there. There was an instance where some folks had extra guardrail after a project and they built a snow fence out of it. You can see it's working very well at trapping snow. And on the right-hand side, this is a picture in Montana off a state highway. And it's a concrete beam snow fence that was built. It's held up great for years and it looks beautiful. So again, there's plenty of options, especially if you are willing to be a little creative. For the purpose of this project, we talk about temporary snow fencing in 2 different ways. It's kind of a catch-all for some type of snow fence that will not last that long or that will be set up and then taken down or moved seasonally. So for example, on the left, we have your typical orange plastic snow fence that people see. This might be something that you have to go in the fall and set up and then take down in the spring, or you get to leave it up the year round. That's part of that landowner agreement that you have to set up. And as I mentioned, cribbing on the right here, this is technically a temporary snow fence because it only lasts a few years. this next slide, just more examples of what temporary snow fence may be. You can get very creative. You can put plastic snow fencing on a more kind of semi-permanent wood frame structure. And then on the right-hand side is something called a snow snake. This is an example that was developed by Tabler. It's a woven hoop, basically, that is used out in a field to catch snow. And it is something that you could build, purchase, or install if you're interested. So just a lot of options out there. There's already been discussion of living snow fences as well. These are seen frequently across the US. These are typically a combination of trees and shrubs, 1 to 3 rows deep. As you get into building these, there are great design manuals out there, and they will tell you this, but it's really important to consider the height of the plants at maturity in your design. And then as you wait for those plants to grow to maturity, you can have a structural snow fence in place, as is shown in this picture. At this time, the structural snow fence is doing a lot of the work here as those plants are growing up to maturity. And then this is an opportunity and also a challenge to work with landowners and conservation groups for permissions and also maybe help. And this next slide shows a great agreement. This is those standing corn rows that were mentioned, technically a living snow fence, but it's an annual one. These can be 3 to 15 rows deep. Typically you want about 30 feet, ideally, of plant material to help create this living snow fence. And then this is great because it's an opportunity to share with the public what purpose this is serving. This happens to be an image from Iowa DOT, but there are other images in the guidance document where the local conservation group made a sign. And then there's also opportunities that we talk about in the guidebook for like FAA and other groups harvesting corn from these living snow fence areas to help kind of create more community understanding and participation. Earthwork grading is an option, and it was mentioned. Dean talked about this, and basically it's an opportunity where you can cut back your slopes and create flat bottom ditches to prevent snow from drifting onto the road and also creating more snow storage. So you're modifying the topography around the road to help reduce snow drifts on the road. This is typically done in the construction phase. So if your road is already built and you've identified an issue in this area, you may need to wait until you have another pavement project or some other construction related project, because it could be expensive to try to kind of reshape the road environment, but it is an option and there's great guidance out there on how to do this. And the last example I'll show is snow bridging. Jared mentioned this. Basically, you can go out in the field with permission from the landowner and you use your equipment and you create these snow berms, and they function as snow fencing. They do fill up throughout the season, so you might have to go out and clean it up and reshape them. But the great thing about this is it's just personnel and equipment. You're not putting any structures out there. So it is an option that is done quite a bit. And then just some really kind of creative options that are out there. There have been 2 solar snow fence projects. They've effectively shown that you can capture enough energy to run, for example, like an RWIS site or power a structure. So if you have a remote location that you need to power maybe an information site out there, this might be a good option for that. Another example out of Wyoming is creating floating structural fences so that you can put these over utilities and you don't have to worry about the rebar cutting into the utilities as you anchor them. And finally, we have 2 other examples. So the picture on the left is from the Blackfeet tribal land, and this was a project done in conjunction with students, and they built a woven willow snow fence on school property. So a really cool example of kind of working within the community. And on the right-hand side, this is just showing what those hay bales might look like as they're stacked near the road to help prevent snow from drifting on the road. So knowing all that these are just general snow fence or blowing snow mitigation strategies that are out there, we also wanted to help the DOT kind of understand maybe what might be the best option for them. So there's a big portion of the guidance document that talks about the adjacent landowner and just different ways to work with them. And as folks have mentioned, a handshake agreement is great, but in some instances, you do want a legally binding document, and that protects the agency, but it also protects the landowner. And then other aspects of this are site-specific considerations, such as topography. Like mentioned previously, just because we identified the top 100 locations, that just means it's been identified as a problem area. Now what they need to do is go in and do a specific site assessment for each of these and design for each of these. So understanding all these pieces is critically important. If you are thinking about doing corn rows, you need to understand the relationship where they rotate the crops and the years that they don't have corn growing and they have soybeans or some other plant. What are you going to do for snow drifting those years? Cattle was mentioned. It can be a huge problem. They like to pop boards off, so you have to go in and maintain those. It was also mentioned that you may not be able to grow a living snow fence in that area. So what other options do you have? And then again, bridges and structures can actually create drifting situations. So how do you either fix that or prevent that from happening? And other site-specific considerations that we talk about are design. We talk very generally. There are really good design manuals out there for structural snow fences and for living snow fences. And we reference these in the guidance doc and in that final report. Maintenance is critical. And we talk about that in detail because you can go through the effort to design and build a snow fence, but if those cattle come in and they pop off some boards, it's not going to function as it was designed to. And then soil, geology, terrain, these all come into play, as mentioned with Dan, that 250 to 1 versus 35 to 1 ratio, that's critically important. And so again, each site investigation needs to consider all these factors. Land use planning is something that we also looked into. If you know, for example, a large box store might be coming in the next decade, you might want to think about a short-term solution, knowing that the way that snow moves is going to change with larger structures. As you can see in this image here, we have a farmstead with trees near the road. They're actually causing snowdrifts on the road. So understanding prevailing wind and all that is critically important. A piece of this project that we didn't have the data to support additional analysis was needed was actually looking at wildlife migration and the presence. Snow fences can actually help create habitat for wildlife, but they can also block migration paths. So it's really important to understand where these animals are moving and how frequently you need to create gaps so that they can get through. So we took all this into consideration and we worked with, again, the local maintenance areas. So for each of the top 100 sites, for example, in this Excel copy here, you can see for the third one down, site 38, we know exactly where the location is. We know the length of that blowing snow issue area. We identified all the potential land and land use adjacent to that, and then the different blowing snow mitigation strategies, and whether maintenance was either already using those strategies or comfortable using them. So for example, site 38, the bottom on this, this chart here, you can see that it is likely that a living snow fence or a structural snow fence would be a really good option here. Temporary would work as well. And we really wanted to make sure that the maintenance folks had a say and a voice in whether or not they thought they would work or they were comfortable using it, because ultimately they're the ones that are going to have to probably maintain it. So looking at all this, we also wanted to know about cost information, and Dean did a great analysis and presented some of that. The literature on cost information for snow fences is dated, and it wasn't great. So what we were able to get out of it was how many years are these different blowing snow mitigation strategies effective? And so we ended up using that in that life cycle cost framework that I'll talk about next. As well as identifying some of the benefits that come out of this, which are, if you can prevent a snowdrift from being on the road, you're improving safety. If you're using a living snow fence, you're encouraging carbon sequestration. If you're using a snow fence, you are reducing emissions, you're providing cost savings, and you're reducing winter maintenance effort and de-icers that are going out there, because they don't need to go out and treat that site over and over again. And again, potentially creating wildlife habitat. So this life cycle framework that I alluded to, it's an Excel-based tool. It's designed specifically for the DOT to use to input all their data into. And there's some set costs that were given to us, but are modified. They're able to modify them. So what is that round trip distance from the shop to the site? What is the length of that blowing snow treatment area? And then what are the base costs for either the land lease or the easement? And then for each blowing snow treatment strategy, what are the costs and the effort that we're looking at? So ultimately, that all gets entered in, and this is kind of what the output looks like. So what we have here is, for all the different treatment strategies, you might have a contract cost or the actual build cost. They requested contract costs because a lot of times they'll actually put it out to bid. And the bid might say, for example, a structural snow fence will cost $7,995. They can just enter that value in. Maintenance costs considers if it's, for example, a structural snow fence, going out each year, doing a walk or a drive of that site, making sure there's no boards missing and what have you. And then you can enter in the costs for any additional boards or rebar or whatever you need. Land use and easement costs, this was provided by the DOT. And then crop reimbursement rate was also provided by the DOT. And this can either be by bushel or acre. These costs are added up and then divided by the life cycle or the years that this treatment might be in service. And based on this example, what you can see here is that the living snow fence, the corn rows, or the earthwork grading are going to be the most cost effective to put in. But with that being said, structural snow fencing and snow ridging are also very viable. Temporary snow fencing is great for a short-term solution, but it is expensive, especially if you're using that plastic sheeting and it's only going to last a year. You have to go out seasonally to set it up, take it down, replace it every year, and that adds up over time. So we created that tool to help them, and they actually said, can you do a cost benefit tool as well? So we took a deep dive into this, and what we found was that there are actually two really good cost benefit tools that exist out there, and there's no need to reinvent the wheel. So we provided the links to where these tools can be accessed. One of them is specifically for living snow fence, and the other one is for all snow fence types. But the framework here shows you all the different costs that go into it and then the benefits that are considered. And I highly recommend, if you are interested in doing a cost benefit of your snow fence program, that you look at both these documents, because what this framework is showing you is kind of a merging of these two options. So with that, I will hand it back to Jamie.
Perfect. Thank you so much. And we do have quite a few questions. So I am going to pull up this webinar page real quick and then go through some of these questions with you all. So we have one question on, for the living fence, do you use different setbacks due to denser porosity?
So yes, so every individual site is going to have its own specific snow fence design. And as Danny mentioned, you know, the setback might be related to the size of the drift that you're forming. So is it a 35H? Is it a 250H? And then the porosity of the snow fence has to deal with when you saw those images of, for example, the Wyoming snow fence, the porosity is the open area between those boards. And the change in porosity can affect that. So for each site, you need to go through, and Tabler created a great design manual that goes through each of these individual steps. So understanding your site characteristics will determine what not only the setback is, but also the porosity. And so there's no one easy answer because every site is different.
And Laura, you talked about a Montana concrete rail style fence. Someone is saying that it's massive, and they're wondering how long the continuous segments are. Were there breaks to allow for animal movement? And was there any evaluation of some of these fence designs on impact to migration or of accidental entrapment?
Great question. Okay, so the Montana concrete beam fence is actually fairly short. It does not create a barrier in any way. It's fairly open, and I believe there's actually a couple that are offset. So migration is not an issue with that one. I know that there are examples of long stretches in Wyoming where they do create a break for wildlife migration, so the animals can pop through, specifically the really tall, big fences like the Wyoming fences. And again, I would work with your wildlife agencies. I think I know with this project, people were really concerned about too much wildlife information being shared because of hunting patterns and whatnot. So you want to be able to design the fence in a way that's going to work for you, but also the animals on the property. So hopefully I answered that question.
Thank you. And then towards the end of your presentation, you also showed a photo that had some trees on the side. And you mentioned the fact that if you knew a big box store was coming in, that you would maybe have some different considerations for what you would put out there. And so we have someone who has mentioned that they are working on a particular type of entertainment infrastructure that they're putting in place. And so they're wondering if there is land development considerations that they should look into for minimizing blowing snow or blizzard conditions.
Yeah, so it's going to really come down to the prevailing wind direction and how close you are to the road. And so that offset. So again, you're going to have to do a site analysis. Again, I highly recommend looking at the Tabler design guide. You don't have to read it all. You could probably just go into what information do I need to know on prevailing wind direction. And then if, for example, you are going to have, like in that situation with the homestead that had those trees close to the road, maybe putting those trees in or taking those trees out would have solved that problem. If you're going to have a building structure that close to the road, that's going to significantly change things. And you might have to work with your local transportation agency to figure out, you know, if there is going to be blowing snow, how are you going to deal with it or manage it? And then maybe if you're willing, you know, maybe you set the building back or the structure back a certain distance. But I don't, you know, this is a tough question because if it's private land and they're following all the zoning and all the permits, you know, does maintenance and the road crew, do you guys have a say in how they design the property? So even just having a conversation or being at the table with them to make them aware of this might help in the long run.
And then I know you've mentioned the Tabler design guide. Someone else is asking what guidance documents or DOT standards would be recommended for guidance on effective grading strategies to mitigate blowing snow. Would it be that guide as well, or are there others they should look at?
Yeah, there is information in there on that. And maybe what I can do as we kind of move to the next speaker is I'll put a link to that in the chat pod so folks can see that.
Perfect, thank you. So with that, we will move on to our final speaker. And then if we have time, we'll come back and answer a few more of these questions that have come in. So our final speaker for the day will be Danny once again, and he's going to talk a little bit about implementation of the information that Laura just shared with you.
Thank you, appreciate it. So after the project was kind of finalized, our next steps are kind of still in the beginning phases. We haven't really implemented anything at this time, but I will be meeting with our executive team here in the next couple weeks to kind of talk about some of our implementations and how we can kind of benefit from this. So moving forward with this project, it really kind of gave us pinpointed our problem areas, and that just kind of gave us kind of the next level evaluation to where, okay, we know the sites that they found. We now have data that we can use and take back to our executive level, or moving forward to ask for funding and kind of stuff like that, or kind of get it into the planning stages. But as Laura was mentioned, she talking about the cost benefit analysis and then the framework system. Utilizing that going forward it's going to kind of give us a clear picture of how to prioritize these specific areas. And then part of the project was give us the top 100 and then kind of give us a breakdown based off of their interpretation, and then we can use that to going forward. So I'm really going to be utilizing that for the prioritization side. One of the other items too are things that I'm going to utilize, or that we're going to utilize from this project, is a lot of education for our field staff, our engineering team, our designers, and then also the traveling public and the landowners. This will kind of help get the landowners educated on it. We do have the data to showcase saying, okay, if you do allow us to either do corn rows, living snow fence, structural, etc., this is what is going to benefit the state with your taxpayer dollars and etc. So that's something that we plan on going forward. One of the other things that I am going to try to implement is making it part of our scoping process when projects come up. And if a project is coming up that we know that we have a blowing snow issue, it will that'll be part of the checklist. Well, now that's going to get more people involved on the scoping process, especially our highway supervisors or lead workers that drive that road every day. Now they'll be able to give the designers a little more heads up of where exactly we're seeing these issues. And now we'll actually have overlay data and cost data to be able to apply for the scope on the scoping side, and as well as the planning and the design side of it. So overall, it's going to be a big implementation, and it's really going to help us out in the long run for helping the traveling public, and then also hopefully reducing our maintenance costs in a lot of our rural areas. So other than that, I don't really have much more. Like I did mention that I will be I am going to be addressing this to our executive level team and kind of see how we want to implement this moving forward. But I will open it up to for any questions that anybody may have.
Danny, before we do that, I just want to make one additional comment on these living snow fences. Is the logistics to coordinate, there was comment about planting and heights and offsets. A big research we did was also what plantings will survive. So working with agronomists to know what'll survive in what soil. But then a logistical challenge for us is actually getting water to those plants. Depending where you are in the country, you have a water source readily available? Are you going to have to expend funds to tap into a water line going in the state right away? Are you going to truck it down there literally with a tanker? And then are you going to put in irrigation lines or have someone literally going along with a hose and going to each plant as it's critical that they get their water early and often? So that's another logistical consideration that one's really got to think about for these living snow fences. The last comment I'll make that I wanted to share is that these temporary features, the hard thing about cornrows and temporary fence and doing a gentleman's handshake is the time to do it is in April, May, when the season is just ending to get ready for next year. We're always in that getting geared up for the next season, and that's paving asphalt roads, fixing potholes, adjusting our snow plows for summer activities. But it often seems hard to start thinking about next winter right at the end of this winter, if that makes any sense.
So I know we're getting pretty close to the end of today's webinar, but we do have a couple of questions. So we'll just try and answer a few of these before we go ahead and get wrapped up, because we do have, again, a lot of experts on here. It's the very first time we've ever done a winter type of webinar. So I'm very thankful and grateful for all of you being here. One of the questions for South Dakota was, what type of software programs are you and other agencies maybe using to model blowing snow when doing a site-specific design?
So really, for the site visits, I haven't not been using any computer. It's more been just using the tabular design manual and then doing hand calculations. I do rely heavily on a project or a computer or a database that University of Minnesota created here multiple years ago that kind of that will do most of your planning for you for your site visit, but you have to put in more of your localized parameters to get by with it. So it's kind of a pain, but for right now, that's moving forward. I would like to get something that would benefit us a little quicker. So we are behind the power curve on a lot of it. But other than that, I'm just doing I'm just working with our area engineers and then some of our design engineers, just working off the tabular design manual.
And I'll add to that, based on our interviews with other state DOTs, and that's in the back of the report if folks want to kind of see, other experiences too. Apparently they were using Geopack as part of a microstation tool, but when they went to a different kind of system, there was a little bit of conflict with that. So that's also one of the challenges with some of the software programs too.
Perfect. Thank you both for those answers. The last question that we'll have for today is, how important did you find crash data as an indicator? The requester is saying that they found many times that roads were closed or had light traffic due to blowing snow, so there were no crashes, but there was still a significant blowing snow problem.
So I'll add from the research side of things. In the document as well, we did look at kind of the crashes as they related to the blow and snow locations that were identified. And so we actually have overlay maps that show the various categories. So that blow and snow one, the winter surface one, and then the winter weather itself. So you can see kind of the relationship or not. To be perfectly honest, with the kind of evolution of how safety analyses are done, would love to see more projects being able to kind of specifically tie some of those. But that's kind of the analysis that we have. So we definitely know that there's relationships to it. But I think kind of that detailed, really analytical one, I think are opportunities for future research.
Thank you, Natalie. And I just want to, again, thank all of our presenters for today. Jenny Varlick, Dean Vanderwilly, Jared Fosham, Natalie Vilwaquity, and Laura Fay. We do really appreciate you coming today and talking about your project. Look forward to taking a deeper dive into looking at that. And also thank you, Laura, for sharing those other resources in the chat pod so that everyone has those available for future reference. So thank you one more time. We appreciate you being here. And we did have some questions about the recording. It will be up within a week on the ruralsafetycenter.org website on our webinar archive page. So thank you again for joining us today.